Hi, my name is Peter. I'm a senior Java engineer too here at Acmesoft, and I'm in charge of updated migrations. So just last week we updated from Java 8 to 21.
It's 25 now.
Sir?
Yeah, I edited that POM thingy to use 25. Heard on a podcast that it's really good.
Oh. No. Oh, no. Oh. Well, looks like we'll have to fix that. Let's see what can go wrong between Java 21 and 25. So I'll update JDK to 25 and run the build. Oh, so what's going on here? Let's check the class. Okay, so this class uses an annotation that Google's auto-value library is supposed to generate code from with an annotation processor, but it looks like that's not happening anymore. Let's check the POM. Okay, so this is the annotation processor, and although that does work, it's not really supposed to just be on the compile class path. But that doesn't work anymore, maybe? Let's see. Okay, there we have it. Annotation processing is a compile time feature where Java-C scans the to-be-compiled source files for annotations and then the class path for matching annotation processors so they can generate source code. Yes. To JDK 22, this feature is enabled by default, but from a current perspective, this is much less reasonable. Starting with JDK 23, Java-C requires an additional command line option. So proc has a new value. If neither processor path, nor processor module path is used, proc only or proc full has to be provided. Okay, so that means if the annotation processor just happens to be on the class path, but nothing else is configured, then it's actually ignored. So what we need to do is either configure proc full for the compiler, or maybe better, just put the dependency where it belongs, which is on the annotation processor path. So let's do that. There we go. And now let's run the build. New error. Success. That's in the AI layer. Let's check it out. Oh, a real compiler error. That doesn't happen often. But that file does nothing. Why would Java-C ever allow that? That was a bug. They fixed it in 22. I'll send you the link. Thanks, Uli. He's a bit shy.
Hallo, mein Name ist Uli Kunkel. I'm a bit famous for my music and movies I start in, so I prefer to hide my face from the camera. I read a lot of blogs like Inside Java, listen to podcasts, watch YouTube, code. Yes, I write code too, of course. I'm an expert. Public, static, void, main. I know all about that, of course.
So yeah, this looks right. Apparently Java-C allowed final in a place where the Java language specification actually didn't allow it. And they fixed it in 22, but also 21 or 3? Wait, were we running an old version of 21? Oh. Hi, Anna.
How's the upgrade to 25 going?
How do you know about that? Aren't you on vacation?
CEO posted a selfie listening to a podcast about it on Sunday. The rest was elemental, dear Peter.
Very funny.
I read something a few months ago that you should know. I'm pretty sure that we defined a security property named include, but that became a reserved word in that context, and we need to make some changes.
You know, I know nothing about that.
It's easy. You can do it. Just open the security properties file and rename include to, I don't know, say inclusion for now, and I'll find something better when I'm back.
Okay.
And also update calls to security get property.
Will do. Thanks.
All good. Have fun with the update. Bye. Poor guy.
That was indeed pretty easy. Still very glad I didn't have to figure it out myself. Okay, let's push forward. It looks like this test fails now with a null pointer exception that's being thrown on some reflective constructor invocation. Let's take a look. So with this test, what's going on here? So that's the inner class, and it doesn't seem to have a constructor, but there's always an implicit constructor that takes the enclosing instance and assigns it to an implicit field. And why would that be null? Oh, so this code uses reflection to create an instance of an inner class with a null reference to the enclosing instance? And this fails now? Let me check. Starting with JDK 25, when Java-C is targeting release 25 or higher, it will emit null checks for the enclosing instances in inner class constructors. This behavioral change will lead to new NPEs in code that uses core reflection, method handles, or direct bytecode invocation to pass null as enclosing instance. Yes, that's what we're doing here. Such code is rare and usually found in libraries or frameworks as opposed to in applications. Well, we're special. As our CEO likes to say, we're Acme soft, but we go Acme hard. It should be changed to no longer pass null reference. Well, that should be easy here, but what if this shows up in one of our dependencies? Guess I'll open an issue then, maybe even a pull request. Let's run the build. Ha, there it is. Green build, always an important milestone. Very good. But what's going on here? Warning, a terminally deprecated method in sunmisc unsafe has been called. Sunmisc unsafe object field offset has been called by Guava. Object field offset will be removed in a future release. Wait, I think I've seen a video about this. Let me check. Inside Java newscast. Let's go here.
JDK 24 also removals in JDK 24. The Java platform makes a lot of promises, from type safety to its memory model, from visibility modifiers to finality, but they all hinge on one core property: integrity, the guarantee that the platform upholds the promises it makes. At the same time, Java offers a bunch of mechanisms that can undermine this integrity. Reflection can sidestep visibility and finality, Unsafe can corrupt memory, and native code can easily straight up crash the JVM. Under this tension, Java is currently developing a principled stance: integrity by default. Operations that can undermine integrity are either replaced by alternatives that cannot, or will be disabled by default to be enabled on demand by application operators if they deem the trade-offs beneficial. And JDK 24 is taking further steps down that road. First, the memory access methods on sunmisc unsafe that were deprecated for removal in JDK 23 will now issue a warning on first invocation. This behavior can be configured with the command line option --sunmisc unsafe memory access, which accepts values allow, the default in JDK 23, warn, the default on 24, debug for more information, and deny. And I highly recommend to run your app with deny to prepare for a future where it will be the default before the entire option is eventually removed together with those methods on unsafe.
I've been searching a bit on the site and found two more unsafe related issues in the OpenJDK bug tracker. One, remove the methods should be initialized and ensure class initialized, and the other deprecated park, unpark, get load average, and the fence methods for removal. Okay, let's see what else that YouTube guy has to say.
And second, the foreign function memory API used to require the command line flag enable native access to allow execution of so-called restricted operations, those that can undermine integrity. Now JDK 24 temporarily downgrades a lack of that option from error to warning so that it can onboard the Java native interface, which used to just allow access to these potentially troublesome operations. Now both APIs contribute to the list of restricted operations, access to which is uniformly managed with two options. Use enable native access to allow access for specific code, and use illegal native access to configure how code that didn't get the green light should be handled. That last one will get stricter over time, with denying such access being the inevitable default.
Okay, that all makes sense. But what does it mean for these warnings? Wait, surely I can't be the first one to have this problem, right?
What version of Maven am I using?
Oh yeah, no, that's not exactly the latest.
Okay. There we go. 2 steps forward, 1 step back. What's up with unsafe, static field base, and juice? Okay, let's check. So it's known and it will be fixed. I'll just make sure to update everything regularly, which seems to be a good idea anyway. But I wonder whether our dependencies do any of that. How can I find out except looking for these warnings? Use jnativescan. It's a static analysis tool that scans one or more jar files for uses of native functionalities, such as restricted method calls or native method declarations. And jdeprescan for good measure. It scans jars for use of deprecated API elements. Okay, thanks.
Peter!
I need just a minute.
Rare. But its maintenance burden remained. And so in 2021, OpenJDK decided to phase out the security manager by deprecating it for removal in JDK 17. Now, JDK 24 takes the next step and permanently disables it. Setting the option Java Security Manager to any value except disallow will lead to an error. And calling system set security manager will throw an unsupported operation exception. A few more options are impacted, but importantly, the class security manager as well as related methods remain for now, but are changed to have no effect, for example by doing nothing, returning false, etc. If your project uses the security manager, or even if you're not sure about it, please check out JEP 486 for a lot more details on the motivation, the current process, and future work.
There's more, you know. I'll send you the link. Because the security manager will be removed, the Java Authentication and Authorization Service API needed to be updated. Calls to subject do as need to be replaced by subject call as, and subject get subject by subject current. So apparently Java 22 and 25 fixed some weird file system behaviors on Windows, which is why it was our CEO who found them. 3 things. File get canonical file through an exception for a path that starts with \\\, even though that is legal on Windows. Yes, we had code that depended on that. No, I'd rather not show you. It's gone now anyway. Then, apparently Java accepted directory and file names with a trailing space, even though Windows doesn't allow them. Well, it no longer does. So some calls to file makedir return false now, file create new file throws an OR exception, etc. And lastly, file delete no longer deletes read-only files and instead returns false. We didn't really fix that because our CEO found that there's a command line option that restores a legacy behavior, and he thought that would be faster than updating the code. It's fine. This is fine. Options like that never go away. The COMPAT option went away. Oh no! When moving to 21, we noticed that Unicode was updated to version 42, which changed quite a few things about how dates, times, and units are formatted and parsed. It was decided up high that we'd set the system property Java locale provider to COMPAT so we wouldn't have to update any code. If only we'd known that COMPAT will be removed in a future version. There was a warning.
Shut up, Uli!
I got links for you, though. Send me the links. So, yeah, COMPAT is indeed gone. And the only remaining options are CLDR or custom locale data provider. But CLDR is definitely the way to go, and I hope we'll switch to that. In the first helpful change of the day, Java 23 introduced a lenient parsing mode that more loosely matches spaces and doesn't insist on the non-breaking and narrow non-breaking spaces that CLDR 42 uses. For classes from the package Java time format, lenient parsing needs to be explicitly set on a datetime formatter builder, but it is the default on the Java text package, where it can be turned off though. That could solve our problems, or at least some of them. Java also updated to CLDR version 44, which brings a few changes that I have to look into. Like Mexico and Latin American countries changed their time formats from 24 hours to 12 hours, and Australia and the United Kingdom no longer have a comma after the weekday. This will probably take me the rest of the day. Good morning. I had to clock some overtime yesterday, but I did finish the time zone migration. 5:30, that's why I got myself an extra strong cup of coffee. But I'm in a good mood. I'm pretty sure from here on out it's going to be smooth sailing.
TCX is down.
What?
TCX is down. Everything is gone on Java 25.
Okay, I look into it. TZX is an old desktop app the CEO wrote 4 startups ago during the year of Linux on the desktop. It's special and so are its users, but it's the only thing that generates cash flow, so I need to take a look. Okay, so the banks, our customers, insist on running OpenSolaris with GNOME 2 from the late noughts on their fleet of cheap desktop PCs that they bought around the same time. Thing is, those are 32-bit machines, the port for which was removed in Java 25. On top of that, their GNOME still uses GTK2, which got its last update in December 2020. Kinda impressive, given that GTK2 was first released in, I want to say 2002? Anyway, Java 24 dropped support for GTK2, so there goes the native look and feel. Do you think we'll get them to update their infrastructure? TZX is short for time zone something. Nobody knows what the X stands for. I think our CEO just likes the letter. Anyway, it relied on the system property Sun Time Zone ID's old mapping to handle the terribly outdated time zone IDs EST, MST, and HST, all of which were removed too. But that's not all. We also never got any budget to update the arcane launch script, which uses the weirdest command line options. He really went egg me hard there. Check this out. So all of those are gone too, I'm afraid. Let's figure out what they did, and it's like, I wish we would have maintained this launch script to know what all the options are doing. TZX is also highly concurrent, so it needed a highly optimized concurrency framework, which was custom built over 15 years ago, and since the code isn't very amenable to regular maintenance, it hasn't been touched since. It still uses the suspend and resume methods on thread and thread group, as well as thread group stop, even though they were already deprecated for about a decade back then. And yeah, they're gone now too. Looking for other removals, I found 2 more. JDK 18 re-implemented the reflection API with method handles, and for a while both the old and the new implementation were available. One could be selected with the system property JDK reflect use direct method handle. Apparently that new implementation did its job well because 22 removed the old one, and so now that system property is a no-op. And the other change is that the random number generator algorithms in the module JDK random got moved into Java base, and JDK random itself got removed. The fix is easy, just don't mention that module anywhere. The random generator API is now fully usable with just Java base. We're not impacted by those changes because we've not seen the underlying technologies from 2022 and 2017 respectively. Yay for us. But we'll do better now. I saw warnings for these command line flags, which are being removed because more consistent aliases exist. And compressed class pointers will be removed soon, so the rated options are deprecated too. And then there are the modules JDK Crypto EC and JDK JS Object, also deprecated for removal. Crypto EC because the code is moved into the base module, and JS Object because the 2 types it contains are unused within the JDK. I won't let all that surprise us in a few years when we update to the next LTS version. Actually, there are no LTS versions. Shut up, Uli. Everybody knows what I mean when I say that. As I was saying, I won't let that surprise us again, so let's fix it now. Should be easy.
Hey.
Hi, you're working from home today?
Yeah, Anna warned me the CEO was going to make a mess, and I decided to steer clear of that.
She warned you, but not me? So what's up?
So the logs are weird.
What do you mean weird?
I'm using Xlog to track Metaspace, but the messages don't show up anymore.
Since we updated to 25?
Yeah.
Okay, let me look into this. So this is the log configuration Billy is using. Let's run it on JDK 21. Okay, so here are the blocks of the individual collections, and there at the end we find the Metaspace info. Okay, now let's run that on JDK 25. Just the one collection, which, I don't know, maybe that's better. but also no Metaspace info. Okay, maybe there's a different tag. We can see all messages with the GC tag with the asterisk here. And so this then is the collection, and there in the middle, there is the Metaspace stuff. Okay, so it does have a different tag. It now has a Metaspace tag. So let's give this a try. Metaspace. Oh. And yeah, now we get just the Metaspace messages, which Billy is probably going to be happy about. I'll call him, let him know. Problem solved. These messages are just tagged differently.
Thanks, but now we have a bigger problem.
Come back when it's a catastrophe.
Very funny. Remember how we used jstat and jhsdb to observe the JVM?
Let's pretend that, yes?
Specifically, remote JVMs?
Let me guess. That doesn't work anymore.
Well, it still works.
Finally, some good news.
But it's been deprecated for removal.
Son of
Language! But I have a solution. Remember that handsome guy who talks about JFR on the Java YouTube channel?
the dork with the weird hair and tattoo?
No, the other one.
The dork with the weird hair and no tattoo?
Yeah, him. So he's been showing JFR pretty hard for a while now, and it can actually solve our issue because it can do remote JVM observation.
Makes you wonder for how long though.
What?
Never mind, just glad this resolved itself so quickly. I'll look into it though. Bye.
Bye.
I can send you the link. Okay, so JStat and jhsdb are still fully supported. It's just their RMI-based remote connection that is deprecated for removal. Because RMI sucks. I mean, that's not what it says here, but that's probably what it is. Feels like we ran into pretty much every migration challenge between 21 and 25, but now it's all green. I mean, blue. Nice. And now we're ready to use all the new features. Pretty sure Billy is looking forward to ahead of time computation to improve launch times, and Anna to take steps towards post-quantum encryption, and there's language and API improvements, of course, but somebody else needs to talk to you about all that. I need a vacation now.